just to pick up where I left off there today, in case you get a chance to do a little bit more work on structural forms. So just to revise and look back, the set of straight line elements that touch through the throat circle right here, going from base through the throat to top. That's this guy, from the base through the throat circle and up to the top, and from the top through the throat and down to the base. Top through the throat down to base. Those two are true lengths. They're the exact same length as all others, but the others don't appear as true lengths. As a second note, the straight one that goes through the throat circle here would be seen as a true length in the end elevation, but in this one here it appears vertically in plan, going from the base through the throat to the top, and in elevation, base through the throat up to the top. And the more you draw, and especially if you draw the second direction as well, so let's say I drew that one from base to top only, base to top only, but I could have also, or did I get the second one in? I did, I got from the top down to the base as well. The more you draw, the closer you start getting to this curve here, which is a hyperbola. So the more you draw, the closer you get to this hyperbola right here. At the distance from vertex, and that's the vertex of the curve, so it goes from the base to the vertex to the top. There's the base of the curve, the vertex and the top. The more straight line elements you draw, the closer you're getting to this curve here. You have a vertex and a vertex, which is, back to conic sections, that's the transverse axis, the distance between the vertices. Taking it from there, when you flip over to the back of the page, just a very quick little look back again on conic sections here. This is a very quick one to do, and you can apply it over here on the right. So just to remind you of the method here, you can plot out a few points outside the focus there, and I'm going to plot out point 1, point 2 and point 3. And if you remember when you studied conic sections, it was always from the vertex to the point from the focus, and same rule from the vertex to the point from the focus. And that was our method of constructing the points, which will eventually give you, there's one hyperbola and the exact mirror image hyperbola over here. And obviously you'll plot out your points 1, 2 and 3 here on the left as well. So from the vertex to the point from the respective focus. You can now just practice the method used over here. Okay, so and don't forget as well, just as another point of note, from the focus to any point in the curve, we call that point A, and back to the second focus. If you subtract the distances, so take the distance of the small line away from the large line, we're going to be left with that right there, which is the transverse axis, which is the very same as the distance between the vertices, the transverse axis. And all of the stuff that comes with that, like the auxiliary circle then and the asymptotes and so on, that all comes after. Now that's structural forms sheet 2, on to number 3. And here in sheet 3, it's, maybe I might have, yeah, I probably should have done the 2D method on the first page. This is more practice of that, of the element method here. So hyperbola of revolution is made up of an infinite number of straight line elements which are inclined to the conjugate axis. Conjugate axis being this guy down here, and the inclined straight line elements. And then here in the center at the narrowest point is your throat circle. And the more elements you draw, let's say again from the base through the throat circle and up to the top, the more elements you draw, the more accurate it's starting to look and get towards being a perfect hyperbola of revolution. Each element is tangential to the throat circle, and yeah, so look, the question they're asking you this time, that's a throat circle here, that's an element here, that line is, and they're just saying to practice what we did there back at the start again. And it says use 12, so 30 degrees and 60 degrees and vertical 60, 30 and so on. And is it 12 in one direction or in each direction? I think they're all omnidirectional, they're all running just the same way. So a bit more practice for you there on sheet 3. Now here on sheet 4 we're looking at our next method. So a couple of the key principles: any point in the surface of a hyperboloid or revolution is contained on two straight line elements. The hyperboloid or revolution is a doubly doubly surface. All elements are tangential to the trough. Any section perpendicular to the conjugate axis is a circle. The conjugate axis being the main axis running down through the object, and any perpendicular section through that will just give you a circle. And a section tangential to the trough circle and tangential to the trough circle, so standing up and parallel to the conjugate axis, so that vertical section plane that's right there will produce two straight line elements, and these elements will appear as true lengths. Okay, so look, here's our next one. So, photograph of a car showroom is shown here, and the right part of the structure is the shape of a hyperboloid or revolution. The projection of the base and one element are shown in the diagram below. So the base is shown here, and one of the elements going from A through the centre and up to B is shown. Rotate point A in a clockwise direction about the axis OP, the axis being there. Rotate point A clockwise and onto the section plane SS. So look, we'll get to that in a second. What can I fill in here first? I suppose I am filling this in. So in the rotation of that element about the conjugate axis, point A goes out to SS. That gives me the point on the base. It also gives me the top. There's the top. Okay. And also do then is take point B up. I'm going to draw the base. Actually, the base is already drawn for me. It's from there to there. I'm going to draw the top circle, or the top, which is based on a circle right there. What else would I like to have? I'd like to have the trough circle drawn. So I'm going to draw that. And if I'm given those true length elements going through, going through from A to B, I can now rub out my little mess there. And draw the trough circle. Excuse the inaccuracy with that one. The trough circle comes from the centre. The size of it comes from the plan. Doesn't always have to be heavy, I'm just doing it so it comes up in video. There's the trough circle. Now, using a series of points, okay, rotate point A in a clockwise direction about the axis OP. A goes clockwise out to as far as the section plane SS. Now what does that look like? As A goes out to SS right there from OP, what's it look like? Well, it's just A going out to there. And using a series of points on the element to produce one branch of a double hyperbola. So this is M2, method number 2 here. The first method was just by drawing a load of elements, or 12 different elements, all different directions. And the second method here is a little bit different. So what we do, we're going to pick a few points. So we're going to lay a few points down up along the element lines. And we might lay 4 points down. So I'm going to lay them down here in plan. In plan it's approximately 20. I'm going to go 5, 10 and 15 there. 3 points will do. Okay, I'll call them points 1, 2 and 3. They are just a point on a line. I'd like to find those same points in the elevation. 3, point 2 and point 1. Now I'm going to do the rotation. So I'm going to go clockwise, but I can't see the back of it. I'm looking for this curve here as it appears in elevation. I'm going to rotate point 1 around until it reaches the curve. I'm going to rotate point 2 around and point 3 You know, in my case, there's a fourth one here in the sketch. And if I can get all those points, I'll have a base point and a throat point, and I'll have more to join through. So let's go for that. I'm going to rotate point 1. I'm going to rotate point 2 and point 3. That's the 3 then done. The new point 1 in the cross-sectional position SS, the new point 1 is up there. What does the rotation look like? Heights don't change as we rotate, so there's the new point 1. It's right there. I have the new point 2 and 3, and they just come across 2 and 3. And there we go. That's one portion, and you can finish the next one up. You can mirror them across, or you can go for point 4, 5 and 6 if you want some more practice. But that's going to be it for that question. The 2 notes that are missing here, throat circle and straight line element. Your structural forms, sheet 4. Make sure you're familiar and comfortable with that method right there, very important method. Now here on sheet 5, I'm going to go quickly through these because I think at the beginning a lot of these pages are actually, they're easy enough, they're quite manageable at the start. I'm going to do 5 and 6 now, and you should be able to do sheet 7 yourself. Here on sheet 5, this is back to junior cert really, and it's where we cut a cone at an angle and we expose an ellipse there. So complete the elevation of this, or cylinder I should say, complete the elevation of a cylinder using horizontal sections and identify the curve that is generated in the elevation. That's going to be an ellipse. Look, horizontal sections through a cylinder. Top point is here in the center. Now, I can reference the plan I suppose here, down to 45 and across. There's the highest point in the center. The lowest point is going to be here at the front of the object, so that's going to be across there. Highest point and lowest point identified. This one here is going to be the 2 midpoints left and right. So I get that much of my elevation right there. Now, next up, they've asked me to do some horizontal sections. I'm just going to go random here, random positions. There's one horizontal section through the object, which is there. That horizontal section comes out onto the curve here, which is those 2 points, just like that. What does the actual horizontal section look like? With the horizontal section cutting through, but it looks like the outline curve up to that point. So that gives me 2 points in the curve. After a few more goes of your horizontal sections, you'll end up getting your elliptical curve. Now the reason for that is that's like a warm-up activity for the next part here, which is actually quite similar. This time, what is it? Well, it's an inclined section through this object. Okay, the diagram shows an incomplete orthographic views of a hyperbola of revolution, which is cut by the section plane S. Draw the elevation and plan of the cut surface. So look, we're going to be doing something I suppose quite similar again. I'd like to find bottom and top first of all. Bottom and top of the cut. So there, I wonder is that supposed to, it's probably just accuracy now on my behalf. It's probably supposed to be right there. There's the bottom, or the top. And there's the bottom of it working along the center line. And I work over here. There's the bottom. Next, I'll just take any one cut through the object, horizontal cut right there. And that horizontal cut is going to give me 2 points that lie. That horizontal cut is going to look like a circle there, and it'll expose 2 points on the freehand curve. Horizontal cut is there. The size of that horizontal cut, the size circle it gives us, got from here. And the points on that horizontal cut are there. I have them in plan. I can get them in elevation. And if you keep repeating that, and let's say you drop in one more here and one more here possibly, and show your cuts and plans, show them in elevation, you will end up getting a freehand curve that goes from the top down to the bottom and back up. And here it's going to be a much broader curve like that, and it should kind of touch right out on the edge. So there's another little bit of practice. Repetition of what you would have covered when you were doing intersection of solids, taken in here to structural forms when you're given a hyperboloid revolution. And this is very common, where you show a cut there, a cut here, a vertical cut, whatever it happens to be. You need to be able to manipulate that and work with it and see what it's like in the other two views. Very, very common, and you will see some exam questions coming up soon that have that as part of. There's sheet number 5. And finally for this video, sheet number 6. And here in sheet number 6 we are moving away from cuts for a while, and we're back to kind of a real style question, but it's just turned the opposite way this time. So what we're asked, a photograph of an interconnecting bridge here, very cool kind of a structure, very architectural, between two buildings is shown. It's in the form of a hyperboloid of revolution. The projections of both ends of the bridge are shown. The line AB shows a true length of each element on the bridge. And use a true length of the element to find the diameter of the throat circle. Look, right, where do we start even here, right? So the elements are, we'd like a throat circle here, and we'd like to see the element crossing. And if it was crossing there and we look down on top of it, we'd see it as a true length here, crossing. So that's how I'm going to start this. Now, I just measured the length of this, and it's 87 point something. Can't find the centre of 87 point something. So I'd like to find the centre of the drawing. And that's easily done. There's the centre. That's where the throat circle is going to be, but that's where the true length elements will cross, one in each direction, because I'm going structuring it this way. Now I could do it here in the elevation, nothing wrong with that. Throat circle there, elements there, and look across at the elevation. I've just decided I'm going to work with these ones, looking down from the plan. Same system works in either place. I need AB, I'd like the centre of that as well. And the centre of AB is the true length of the element, but I'm more interested in getting half the element for now. When I have half the length of AB, just check I'm accurate there. I'm going to take it, and I've now changed that question back to something that's much handier to work with. I've used the information and worked backwards to show that that isn't a true length element, not the most accurate one now for me, and that is, and they both pass there at a point on the throat circle. Let's work it back again to the end elevation here. My accuracy is well off there, but I'm going to go with it now. And those two blue elements are here. That's them. As we look down on top of them, we see them as a true length. When I see my elements, I see my throat circle. What's next? I'd like to find my throat circle down here, which gives me my two vertices. There's one, through the centre. There's my second one, two vertices. I can do the same up here in the elevation. Vertex and vertex. So I'd say you're starting to see hopefully how this is all built up. What's next? I'd like to get my points down here for my curve. I know that it goes, let's check the accuracy of that from, yeah, the accuracy is quite good there, starts and finishes there and touches the vertex. Same kind of a principle here, really put some points on. Now these can be random or they can be measured. And measure that's 20 mil again, so 5, 10 and 15. That's points number 1, 2 and 3. Find those points on either line, doesn't matter. Points 1, 2 and 3. I'm going to go with near line. There's point 1, 2 and 3. 1, 2 and 3. And now it's time to do the rotation. So we're going to rotate them down until they're in a position that we will be seeing them in plan from the base circle to the throat to the base, which is here. We can rotate point 3, point 2, point 1. And what does that rotation look like? So point 3 in its new position, in its rotated position on the extreme is there someplace here. That's point 3. Do the same for 2. Rotate, project and rotate. Then you get point 2 and point 1. There we go. For practice, or just sorry, for efficiency here, you take point 3 from one side and you mirror it to the other side through the center with your compass. Take the measurement out, flip it across. You can mirror down through the center here to bring them down point 3 down. Sorry, this point 3, the correct one, down to this side. But for the elevation, it might be nice for you to get a bit more practice, and the practice could come here in the form of putting in your elements, standing up vertically there. And what does that look like? Well, that looks like you're going from there and there up to here and here, and they be your 2 true length elements in the elevation, going straight through the center of the throat circle, picking your points 4, 5 and 6, let's say 4, 5 and 6. Find them original points 4, 5 and 6, rotate them down, across, that was number 5, and it drops, and you get your points for this curve. That's structural forms, sheet number 6. And here in sheet number 7 is a nice challenge for yourself to give a try. I'm not going to draw this one. So what are you given this time? You're given the throat circle. Here's the vase. This here is the best depiction of it. You have your base circle here, and you have your top circle here. But then they went and did that much and then extended up further. So it went from base to throat to top and on further. So it's this movement here to here is this extension part right there. So I want you to give it a go yourself. How do you start it? Oh, that's the base circle, given. That's the throat circle, given. Where do you start though? Can you find a set of elements, the true length elements that go from the base to the throat to the top, the original top, before you extend out to the new top? So the original one here is from the base through the throat up to the top, which is here, which gives you the height. Sorry, no, that's not very accurate, that's sketching. The height should be symmetrical in there and there. The extension should go to here. Or sorry, it shouldn't. The extension should go to here, of course. So that's the original element to there, and the newly extended element that went on further goes to there. Find the altitude of the extended, well, I've just shown you that, and now you need to actually draw the full thing. I'd focus on forgetting about this very, very top circle here, this larger one, and just work on what you know already, being working on those two, and work on finding this portion, right and left, and then see if you can add in an extra maybe 2 points to rotate to find 2 extra points there for the extended portion. That'll take you through the first 7 sheets, which is quite a lot of work. Sheet 8, if you're feeling very comfortable and confident with it, is there as well. But by the time you're through from sheets 1 to 7, you're actually ready for some exam questions, which is the good news. That's it. I'm going to leave it at that for this video. It's a bit broken up there into a few different videos, but best of luck with them, taking you through sheets 1 to 7.